Closely related to the abstract class is the interface, but an interface is even more abstract than an abstract class, if that's possible, because an interface provides no working code, simply a list of methods that a derived class must implement from that interface. I think an example will clear up what I'm talking about. If we want to turn the shape class into an interface, we write public interface shape followed by an open curly brace and then our list of methods. So for example, we might have a void setX with a parameter, void setY with a parameter, int getX with an empty parameter list, int getY, then perhaps a void move with an int newX, int newY to move the class object to a new xy coordinate, and a void draw, which can implement some type of draw method. So this is like a contract which states that if I implement this interface, I have to create definitions for this list of methods. So for example, if we implement shape in the class rectangle, then we still have to provide a list of data members. So we still have to have x, y, and then because it's a rectangle, width and height. Then we have to write a constructor, and we'll make it a very simple one. So here we're simply assigning the parameter values to the data member, and then height equals new h. All right, so there's our constructor. Then we'll have to write setX, so we're going to write void setX int x, x equals new x, void setY int new y, y equals new y. We're going to write int getX, return x. I used getters and setters instead of properties. For one thing, to show you a different way to do it, and another thing, it's a little bit easier to work with getters and setters than properties here. We left off a couple of very important things here. Public. So let's add those in. These are part of the interface to the class that implements the interface. Okay. Let's go back and look at this error on shape. Something tells me it's just going to be because it's rectangle. So again, rather than edit out my simple mistakes, I'm going to show them to you so that you'll see how I fix things. And just like me, a lot of your mistakes will be simple typos like these. Alright, so public void move, which takes a new x and a new y, will simply set x and y to these new values. And then public void draw, we're not going to write anything in other than console write line drawing a rectangle at x, y. And I'm not even going to put the height and width information in because it's really not important for this lesson. What I'm trying to show you here is simply what you have to do to implement an interface. I'm not even going to run the code because it's really not that important right now. Again, this is an advanced topic that in an advanced course we'd spend quite a bit more time on, but I just wanted to introduce you to it here. Now, watch what happens if we don't implement all of the methods that are part of the interface. So we're going to take out draw. Now let's go down here and try to instantiate an object, and I believe we'll get an error before even that. So let's go look before we even try to instantiate. It may take it until we instantiate for Visual Studio to pick up the error. So let's try this. Rectangle R1 equals new rectangle 10, 20, height of 15. Here we go. There's the error. So let's read the error. It should come back up, and it may not. It may be up here. Here's my error messages. I'm going to pull them up so you can see them a little bit closer. It says that rectangle does not implement interface member draw. Rectangle does not implement interface getY, interface member. So actually it does, but I made another mistake. There's another typical error. I didn't capitalize the Y. All right, so that's just a typo. But not implementing draw is a mistake. Now it's telling us getY, but if we ran this again and got an error, this time it's going to just tell us it's draw. So come back here and look. It says that rectangle does not implement interface member draw. So that's about all we can talk about in this lesson on interfaces. And again, an interface is just a contract that states if I implement this interface, I must create these methods and provide a definition for them. And it's just one more level of abstraction you can use in object-oriented programming. One of the cool things about interfaces is that one class can implement multiple interfaces. So let's finish up this lesson now, and let's move to the exercise for this chapter, where we work again with polymorphism and demonstrate how that works by creating a collection of objects and iterating through the collection.